So this carbon equivalent is an empirical expression that determines the combined effects of varying alloying elements on the material's hardenability. This has an effect with what heat transfer or temperature levels that must be done to ensure weldability, especially of steel. So this carbon equivalent is normally used to measure the hardenability of steel. Generally, if you have a high CE or carbon equivalent, then the hardness or the tensile strength of that steel or that material increases. But if you have a low carbon equivalent, then that strength decreases. So not only carbon contributes to the hardenability of steel, but other elements as well, especially manganese and others, compute for the carbon equivalent to determine what will be the carbon equivalent, thus determining the strength or the hardness of that specific grade of steel. So to determine the equivalent carbon, so we have this formula right here. So the equivalent carbon is equal to the percentage carbon plus percentage manganese over 6 plus percentage nickel over 15 plus percentage copper over 13 plus percentage molybdenum over 14. So we'll just substitute the value that we've got here in percentage. So it automatically gives us in percentage value. So we just directly substitute this into the equation. So the equivalent carbon here is 0.18 plus 0.34 over 6 plus the nickel value. We don't have the nickel here, so that is 0, plus the copper content, which is 0.35 over 13, plus molybdenum. So we don't have a molybdenum percentage for the ASTM A1065, so we will have that as 0 as well. So remember that for the elements that is not present in the chemical composition of a certain material, so you don't need to put that in the equivalent carbon equation. So 0.18 plus 0.34 over 6 plus 0.35 over 13. So that will give you an equivalent carbon of 0.2635% or 0.26% equivalent carbon. So the threshold for preheat for the need for preheat is 0.45. So if you exceed 0.45 equivalent carbon, so that means you will need to have this material preheated at a certain temperature. So the levels of preheat, as I've mentioned earlier, will depend upon the equivalent carbon that you have present in the material. So this depends depending on the material, but this is just a recommended value or a preset limit for the equivalent carbon for the material that will now be needed to be preheated, because as I've said earlier, not only the hardenability of the material is affected by the equivalent carbon, but also the weldability, because as the material gets thicker or gets harder, thicker and harder, the cooling rate decreases, thus the weldability of the material also decreases, because as you cool the metal, a lot of discontinuities can happen. So you need to preheat that in order for the metal to be easily weldable, and you can also use more acceptable or more commercially available electrodes for that application. So if you need further guides in writing WPS or practice questions regarding the CWA exam, I have the playlist right here. So if you've enjoyed this type of video, please don't forget to leave a like and comment down below for further questions. Also, please subscribe to this YouTube channel if you want to become a CWI. Stay tuned for more. See you on the next one.